Is there food floating around in your bloodstream? I'll see you inside. So that intro may have sounded a little bit vague and odd, but I'm actually going to talk about what's referred to as intestinal permeability. And this is the phenomenon where you actually have small gaps in your intestines that allow incompletely digested food to actually escape from your gut where it should be being digested and actually get into the rest of your body. And now, unfortunately, undigested proteins and other food molecules like this are not welcome anywhere else except for the gut. Quite simply, if these undigested food molecules get into your bloodstream, they're not seen and recognized as food. Rather, they're recognized the same way we would recognize a flu or a virus. So let's start from the beginning. So the gastrointestinal system is actually coated by what is referred to as an epithelium. And this is just a lining that provides a barrier between the intestines and the external environment. And inside of the gut, specifically the lumen of the gut, there are actually trillions of bacteria and microbes that are very important for properly digesting food and for our immune function. So what some may know and some may not is that food actually has a profound number of what are referred to as foodborne pathogens, which are simply just bacteria on our food that we will ingest and recognize as pathogens if they get into the bloodstream. However, the first barrier that these pathogens face is an extremely acidic stomach, and most of them are actually killed off if our stomach pH is low enough. And some that do get through are contained and neutralized inside of the gut so that they can't get into the bloodstream and cause this inflammatory response. With that being said, the transfer of molecules from the gut into the bloodstream is controlled by the permeability or ability of molecules to get past the epithelium. And what regulates the permeability are these things called tight junctions, which are simply just different molecules and proteins that hold the epithelial cells together. And depending on how tight or loose these junctions are, this will regulate what can and cannot pass through the gastrointestinal tract. So an increase in the space between these tight junctions increases the permeability of the gut and makes an easy passage for bacteria and other products inside of the gut into the bloodstream. And this is what is referred to as leaky gut if it gets too large. And when these pathogens are inside of our bloodstream, they cause an immune response. It's almost like catching a cold through the food that we eat. A cold is simply just a response to a pathogen inside of the bloodstream that is foreign. And if we eat a portion of food and it escapes from our gut into our bloodstream, this will cause the exact same cascade. And more research is coming out that it appears that leaky gut can actually be an underlying factor of autoimmune disease. So an autoimmune disease occurs when the immune system begins to produce what are called antibodies. And these are simply just immune cells that can detect a specific type of pathogen and destroy it. But what makes it an autoimmune disease is when these antibodies are referred to as self-antigens, or simply antibodies that we create that can actually attack and destroy healthy tissue. So these self-antigens are able to detect and destroy healthy molecules contained in healthy tissues. So what's also interesting is that underneath these epithelial cells, there are a number of immune cells, and these play a critical and essential role in maintaining our intestinal homeostasis. And they actually help to regulate the tight junctions and make sure that we keep nutrients inside of the gut that should not be escaping into the bloodstream. However, it's very easy to kind of throw off the balance of the immune system and the balance of bacteria inside of the gut. The digestive system has a bunch of different mechanisms to try and neutralize and kill any pathogenic bacteria. However, when some of these mechanisms aren't functioning properly, bacteria can actually multiply, and this immune system that underlies the gut will mount an inflammatory response to try and kill the bacteria, causing this intestinal inflammation. And if we are unable to actually stop these bacteria from continuing to multiply, this process could occur for a long period of time because the bacteria continue to multiply, so we continue to mount an immune response. And there are a few things that seem to allow bacteria to multiply and proliferate. The pH of our stomach, as I mentioned, if that is not low enough and not acidic enough, we will not kill off as many bacteria and the bacteria will begin to build up. It also appears that stress actually causes these bacteria to build up. And now I have heard a lot of people say that stress causes poor gut health and can damage the gut, but I haven't really heard a good explanation of it. But if you've listened to the episode I recorded on cortisol, it actually makes sense what the mechanism is. So when we are stressed, we will have increased levels of cortisol. And cortisol will actually reduce the function and activity of the immune system. And as I mentioned, the way that we kill off these bacteria is through the immune system that underlies the gut. Therefore, if we have high cortisol, we will actually not have the inflammatory response to locate and destroy any of the pathogenic bacteria, which allows these bacteria to build up and begin harming the gut and the integrity of our intestines. Additionally, the entire chemical and bacterial composition of our gastrointestinal tract influences the immune reactions and all of the nutrient uptake that we have. If we have specific bacteria inside of our intestines that are causing us to upregulate our immune response, this can actually begin damaging the lining of the gut, and it contribute to autoimmune disease because we may just have a dysregulated immune response to self-antigens. For example, you may have heard of bacteria such as Salmonella, Giardia, and H. pylori, and these bacteria can actually decrease the strength of our intestinal lining, making it more permeable and damageable. And it appears that if we have digestive issues, specifically not having enough stomach acid, it actually reduces our ability to fight off and kill these bacteria, and it will amplify our likelihood to get leaky gut. And this is where having low stomach acid seems to be contributing to leaky gut. With that being said, there are also food molecules that are found inside of foods that can also cause this leaky gut phenomenon. And one specific one would be a lectin. And now I hope to do an entirely separate episode on lectins because they're actually extremely interesting. However, they do seem to play a role in autoimmune diseases. And actually, I do want to mention one study that has been done that kind of demonstrates how the gut can really interplay with an autoimmune disease. So one of the ways that different molecules can get from the gut into the brain is through a specific nerve called the vagus nerve. And interestingly, some people who used to come in with autoimmune diseases that were affecting their cognition and brain function, they would actually cut this vagus nerve, meaning they didn't really have this connective system between the gut and the brain. And when they cut this vagus nerve, many of their symptoms, if not all of their symptoms, seem to actually get much better. And I think this is just a beautiful demonstration of how the gut can affect so many other parts of the body. And now if we come back to lectins, what we should know about lectins is that they are a protein. But additionally, it's important to know that every single organism, from humans to plants, actually contain lectin molecules in our healthy tissues. The only difference is the structure and function of these lectins. Some foodborne lectins are able to actually attach and damage healthy epithelial cells and open up these tight junctions and allow other pathogens into the bloodstream. Additionally, the lectins themselves can get into the bloodstream and begin binding on to healthy cells. And when they bind to healthy cells outside of the gut, they do the same thing as they did in the gut, and they begin just making the cell malfunction and not allowing for healthy tissue to do their job properly. And then to eliminate the lectin, we have this immune response, and remember that with an immune response becomes a memory antibody that can remember and find the same lectin molecule in the future. And now the adaptive immune system, or the process of making memory antibodies is extremely complex. And it appears that the formation of these antibodies is kind of like a guessing game. And what I mean is that we actually just begin to create millions of different antibodies to see if any of them can react and fight off a specific antigen. And we simply just recycle all the ones that don't appear to work well, and we keep any of the ones that are usable to fight off these antigens. But let's say in that process of trying to make an antibody to fight a specific lectin, we create an antibody that actually binds extremely well to one of the lectins contained in our healthy tissue. We may actually keep this antibody around and begin mounting this immune response to this healthy tissue, which once again is the entire impetus of an autoimmune disease. So what started this entire cascade was the lectin itself damaged the gut lining, and then other lectins, or even the same lectin, was able to get into the bloodstream and cause our body to make antibodies and immune cells that fight off our healthy tissue. The other prominent autoimmune disease you may have heard about is celiac disease, and this actually occurs as a response to the ingestion of gluten-containing grains. So there's a specific protein in gluten called gliadin that is responsible for damaging the intestine. So this is kind of interesting. So when gliadin reaches the lumen of the intestine, it will actually bind to a receptor called the CXCR3 receptor, causing the release of a protein called zonulin. And then zonulin will begin to break down and loosen the tight junctions. And then small segments of the gliadin, called peptides, are actually able to get across the epithelial because of the damaged tight junctions. And these gliadin peptides can actually bind to immune cells, and these immune cells will begin responding by destroying healthy epithelial cells. Alright, I'm going to cut myself off here before I keep rambling on and bore you to death. And I really just wanted to use this episode as maybe just some explanation for a lot of the sayings that we hear. It seems that there are a lot of sayings like an unhealthy gut can cause a disease, and as I mentioned earlier, how stress can affect the gut. But at least for me, when I hear things like that, I don't really quite understand what the mechanism behind it would be, and it doesn't really resonate with me. So I hope today's episode was able to kind of explain some of the mechanisms that underpin a lot of these sayings, and hopefully demonstrate how there definitely is a degree of interconnectedness between the gut and the entire body. And now obviously I and even a lot of the experts are just scratching the surface on the complexities of gut health. But as I keep learning more and more new things, I will definitely continue to keep sharing them. With that being said, I hope you enjoyed today's episode, and I hope you come back and listen to the next one. So I want to say thank you for listening, and have a great day.